Hello students, welcome to chemistry classes. Under this P block elements, today we are going to discuss the chemical properties of group 14 elements. So first of all, reactivity towards oxygen. All the elements of group 14 when heated with oxygen to form oxides. The group 14 elements form two types of oxides of general formula MO and MO2. Monooxide and dioxides are formed. The monooxides readily reacts with oxygen to form complex compound, especially this lead monooxide. This lead monooxide is called litharge. This lead monooxide reacts with oxygen at the temperature of 673 Kelvin. It gives red lead. The name of the compound is red lead. And also the monooxides act as a powerful reducing agent. Reducing agent in metallurgical process while converting zinc oxide to zinc by using carbon monoxide as the reducing agent. Ferric oxide to iron by using carbon monoxide as a reducing agent. The monooxides and dioxides are generally formed by all the elements of the group 14. Apart from this, carbon dioxide, silicon dioxide are acidic in nature, while germanium oxides are less acidic when comparing with silicon dioxide. Stannic oxide and lead oxide are amphoteric in nature. So we know that one of the compound called carbon dioxide. The solid form of carbon dioxide is called dry ice. It is soft white snow like substance and look like a ice. Solid carbon dioxide. Solid carbon dioxide is called dry ice. So this oxides, carbon dioxide reacts with alkalis to form sodium carbonate. Carbon dioxide reacts with calcium hydroxide to form calcium carbonate. Silicon dioxide reacts with alkalis to form sodium silicate, etc. These compounds, the oxide compounds reacts with dilute acids and dilute alkalis. The next property is reactivity towards water. The members of group 14, most of the members does not react with water readily, are inactive towards water, but tin reacts with water in the form of steam to give stannic oxide and evolution of hydrogen. Lead does not affected by water probably because of its protective oxide film on its surface. The third property is reactivity towards halogens. Reactivity towards halogens. All the group 14 elements are readily combines with halogens to form the halides of general formula EX4. EX4. X may be fluorine, chlorine, bromine and iodine. So all these compounds are known, and most of the halide compounds are covalent in nature except some compounds of carbon. And these tetrahalides are covalent in nature, exceptional nature of SnF4 and PbF4, which are ionic in nature. SnF4 and PbF4, these compounds are ionic in nature. And the halides, most of the halides hydrolysis gives different compounds. Silicon tetrachloride hydrolysis with water to gives silicon tetrahydroxide. Tin tetrachloride hydrolysis gives stannic oxide. Stannic oxide. Carbon tetrachloride does not react with water. Carbon tetrachloride is a covalent compound, therefore it does not react with this water. And these compounds, most of the halide compounds act as a Lewis acids, but carbon tetrachloride does not act as a Lewis acids because carbon tetrachloride does not react with water, as well as it is not behave as a acids. And carbon tetrachloride cannot be hydrolysis, while silicon tetrachloride can be easily hydrolysis. This can be easily explained on the basis of absence of d orbital. In the carbon tetrachloride, the carbon atom does not having any d orbital due to the lackage of this d orbital, and it does not reacts with water. The fourth point is reactivity towards acids and alkalis. So most of the compounds are not affected by acids, especially carbon, silica and germanium is unaffected by acids. Tin dissolves in dilute nitric acid. Tin dissolved in dilute nitric acid, it provides stannic nitrate, ammonium nitrate and water. While lead does not react with the dilute acids, but it reacts with the dilute nitric acid. It gives the compound called lead nitrate, nitrogen dioxide and water. And halogens, lead reacts with hydrochloric acid, dilute hydrochloric acid gives lead chloride. Lead chloride further reacts with hydrochloric acid, gives chlorophlumbic acid. Chlorophlumbic acid. Lead possesses greater tendency to react with the organic acid also. Organic acid like that of acetic acid, it gives the compound called lead acetate. Carbon is unaffected by alkalis. Silica reacts slowly with the cold aqueous solution of alkalis and readily with the hot solution of alkalis. Silica reacts with potassium hydroxide, gives potassium silicate. Potassium silicate. Sodium silicate. Sodium carbonate is a base, reacts with the silica to form sodium silicate. Tin reacts with the aqueous solution of sodium hydroxide, gives sodium stannate. Lead reacts with the aqueous solution of sodium hydroxide, gives sodium plumbate. This is also amphoteric nature of tin and lead. Tin and lead are amphoteric nature because both the elements reacts with both acids as well as bases. Formation of hydrides. The fifth point is formation of hydride. Hydride formation is a peculiar characteristic property of group 14 elements. Majority of the compounds, majority of the hydrocarbons are obtained from carbon in the form of hydrides. All the elements except lead of group number 14 tends to form the hydrides of type MH4. The number of hydrides and their thermal stability and their ease of formation decreases from carbon to lead. The significant nature of formation of hydride varied from carbon to lead. Carbon forms a numerous number of cyclic, open chain and closed chain organic hydrides as called hydrocarbons. The common name of, we know the common formula for alkanes, alkenes and alkynes. And the silanes resemblance with the hydrocarbon in many properties. Germanium hydrides are called germanes, having the general formula GEN times H2N minus 4. So, other members, plumbic hydrides are difficult to prepare. So, in this video we are discussing the general chemical properties of the group 14 elements, especially formation of oxides, reactivity towards water, dilute acids, alkalis and formation of hydrides. So, I hope all this understood each and every people. If you have any doubts, you may ask. Thank you.